Hi guys, I am Fuzan Babayeva and I will talk about Gensim package of the Python. Let's look at what we'll talk about today, and our presentation will start with introduction, and we will talk about why we should use Gensim, what's its benefit, what's its popular features and capabilities that make it one of the most usable package. The other part of the introduction about the prerequisites of the installation of this package and how we can install this package. After finishing this part, we will start core concepts and we'll talk about the document, corpus, vector, and model terms. What is them and what are them, and I can show you some examples about these terms. At the end, we will talk about one of the popular model of the Gensim, which is the word2vec, and look at some calls we will use when we use word2vec. Let's start. Gensim, Generate Similar, is a popular open source natural language processing library, NLP, library which is used for unsupervised topics modeling. It used top academic models and modern statistical machine learning to perform various complex tasks, such as building documents or word vectors, corpora, performing topic identification, performing documents comparison, analyzing plain text documents for semantic structure, and others. Apart from performing these complex tasks, Gensim, which is implemented in Python, is designed to handle large text collections using data streaming as well as incremental online algorithm. And this makes it different from the Zeus machine learning software packages that target only in memory processing. Let's talk about the various features and capabilities of the Gensims as well. One of them is scalability. Gensim can easily large and scale corpora by using its incremental online training algorithms. It's scalable in nature as there is no need for the whole input corpus to reside fully in random access memory RAM at any one time. In other words, all its algorithms are memory independent with respect to corpus size. On the other hand, Gensim is robust in nature and has been in use in various systems by various people as well as various organizations by over 4 years. We can easily plug in our own input corpus or data stream. It's easy also to extend with other vector space algorithms. The other feature is platform agnostic. As we know that Python is a very versatile language, as being pure Python Gensim runs on all platforms like Windows, Mac OS, Linux that supports Python and NumPy. Also, it has the features such as efficient multi-core implementations. In order to speed up the processing and retrieval on machine cluster, Gensim provides efficient multi-core implementation of various popular algorithms like latent semantic analysis, LSA, latent rich-weight allocations, LDA, random projection, RP, hierarchical Dirichlet process, HDPR. By the way, we will talk about a little bit about LCA and LDA in model part as well. The other features is about being open source. Gensim is licensed under the OSI approved GNU LDPL license, which allow it to be used for both personal as well as commercial use for free. Any modification made in the Gensim are in turn open sourced and has abundance a community support too. Let's talk about the prerequisites of installing Gensim. Gensim is tested with Python, and we must have the Python installed on our computer. The Python version needed is 2.7, 3.5, 3.6, 3.7. As we know that NumPy is a package for scientific computing with Python, and it also be used as an efficient multidimensional container of generic data. Gensim, it depends on NumPy for number crunching. About the Smart Open, it's a Python library is used for efficient streaming of very large files. Gensim depends on Smart on Python library for transparently opening files on remote storage as well as compressed file. And about the installation, we can use two ways. One of them is using command prompt. We can simply should write pipe install Gensim and click enter, and it's automatically installing. And the other way is using the Jupyter notebook. We use the same words but with this sign. Let's talk about the core concept and start with documents. What's the documents? It refers to text. If we go in some details, it's an object of the text sequence type, which is known as string str in Python 3. For example, in Gensim, a document can be anything, such as a short tweet of the 140 characters, single paragraph, news articles, books, novels, theses, and etc. I use here one of the simplest example of the document, which is a one sentence, small sentence which contains 4 words. Hello, how are you? And what's the corpus? Let's speak about a bit it. Corpus may be defined as a large and structured set of the machine-readable text produced in natural communicative setting. In Gensim, a collection of document objects is called corpus. The plural version of the corpus is corpora. The corpus in Gensim serve the following two roles. One of them is input training model. The other is topic extractor. How it works for the as a input training model? In order to initialize models internal parameters during training, the model look for some common themes and topics from the training corpus. Gensim focuses on the unsupervised models, and therefore it doesn't require any kind of the human intervention, just a need corpus. The other role is topic extractor. Once that model is trained, it can be used to extract topic from the new documents. Here, the new documents are the one that not used in the training phase. Here I am showing you the one of the simplest example of the corpus. It's contains 3 documents, and each document is just the one sentence. And as these documents can be some more complex things such as books, articles, tweets, etc., the number of these documents can increase and can be more complex corpuses as well. And what about the vector? Mathematical representation of the document is called vector. What if we want to infer the latent structure in our corpus? For this, we need to represent the documents in such a way that we can manipulate them mathematically. One popular kind of the representation is to represent every document of the corpus as a vector of the features. That's why we can say that vector is a mathematical convenient representation of the document. One of the popular model of this representation is bag of word BOV models. Here we can see the simplified example, but before it, let's speak about what's the bag of word, how it works. In this approach, each document is basically represented by a vector containing the frequency count of every word in dictionary, as we can see in our simplified example. In dictionary, we have only 4 words because we have simplified one. Hello, how are you? As you can see, we have 2 documents for see the difference and understand how it works. The document 1 is the same with the example of the core concept of the document. Hello, how are you? Due to the fact that each word exists in this example and it only used one time, the vector contain 1, 1, 1, 1. But this example give us more information about the working structure of the bag of word model. We have here, how are you, how. You can see we don't have the hello in this sentence, therefore we 0 stand for the hello. 2 stand for how. You can see here there is 2 how, and the other one is 1 because we have 1 R, 1 U. After vectors, we can now speak about some models and its example. The most used the examples. Model refers an algorithm used for transforming vector from one representation to another. One of the models, the popular models, I can say FastText, use a natural network for word embedding, is a library for learning of word embedding and text classification. It's created by Facebook's AI research lab. This model basically allows us to create a supervised or unsupervised algorithm for obtaining vector representations for words. The second example for popular models is TF-IDF, or term frequency inverse document frequency. This model is a numeric statistic in information retrieval, and it reflects how important a word is to a document in a corpus. It is often used by search engines to score and rank a document's relevance given a user's query. It can also be used for stop wording filtering in text summarization and classification. The other example for popular models is LDA model, which is the latent dirichlet allocation. It's also a technique in NLP that allows set of observations to be explained by unobserved groups. These unobserved groups explain why some part of the data are similar. That's the reason it's a generative statistical model. The other popular models which I want to talk about is LSA, latent semantic analysis model, and it's also the technique in NLP, natural language processing, and it allows us to analyze relationship between set of documents and their containing terms. It is done by producing a set of concepts related to the documents and terms. The last but not least one, and we will talk about it deeply in the next slide, is word2vec. This one is used to produce word embedding, and it's a group of the shallow and 2-layer neutral networking models. The model are basically trained the reconstruction linguistic context of the word. Let's look at the word to work with a simplified examples. In order to work with word-to-wake model, Gensim provides us word-to-wake class, which can be imported from models.word-to-wake. From its implementation, word-to-wake requires a lot of tags. For example, the entire Amazon review corpus. But here I will apply the principle on small in-memory tags for being simple and for our purpose to see how it works and understand their structure. First, we need import word-to-wake class from Gensim.models, as here you can see. Next, we need to define training data. In our training data called sentence, and we use here 5 documents as a part of our sentence. Once training data is provided, I mean, once the sentence is created, we need to train the model. Here we train our model with using the word-to-wake command. And after it, we just can write print model and we can see the summary of the model here. Next, we can access the list of the word used in our training data. For it, we just use the list command, and for indexing each word, we can use word vectors for it comes from here, and index to k commands and list command. It just when we print this variable, we list. We can see each word separately and one list. And as you can see, it's a unique values. There is no repetition of any words. After it, we can access the one word of the vector, one of the words. We can access any of them. I do it for this. See how this model give the vector value to each word. I just choose the Gensim word. As you can see here, the numbers. This number is given by word-to-wake commands, and how it shows how it will convert to these words as a vector. At the end, we try to save this model with this command model.save bracket inside model.b. And after this one, we need to load the model and print the saved models. And again, we see the summary of our saved model. Now let's look at the visualizing. We can also explore the word embedding with visualization. It can be done by using a classical projection method like PCA to reduce the high dimensional word vector to 2D plots. Once reduced, we can plot them on graph. Let's look at the comments. For running these codes, we also need these these classes as well, along with the word-to-wake. After importing these ones, we can start our commands. First, we need to retrieve all the vectors from the trained model. I called the new model A and retrieved it with the code these codes, model.vv in bracket model.vv.index to k. Also, we need to create a 2D PCA model of the word vector by using PCA classes. We can do it with these commands. We can firstly use 2-dimension. We make 2-dimension with n component equal to 2. And after it, we transform this model to PCA and saved the result variable. After it, we try to plot them, and with this part, we will annotate it, the points on the graph with the words itself. I mean, you can see here that each word written the points that show it. For doing it, we use these commands. And you can see the result. You can see each words and its vectorial representations here. And at the end, due to the limited time, I can speak about in detail in each models, in each features of the Gensim. If you are also interested about Gensim, and I think it's very useful for textual analysis, and if you also think so, you can use this for sources because they are very useful and easily understandable, and explain the topics with examples, which make it much more easier to understand how it works and which comments we need to use and how we use it. Therefore, I put this list here, and if you want, you can also use this source as well. And if you have any questions about my presentation or any about these topics, you can easily ask me from Piazza as well. Thank you for your listening.